Function is x, right? So x of s minus s into x of 0 minus x dash of 0 is the Laplace transform of d square x by dt square plus 2 into dx by dt. Laplace transform of dx by dt is s into x of s minus x of 0 plus 2 into Laplace transform of the function x is 2 into x of s is equal to Laplace transform of 2. Laplace transform of constant is what? Constant k by s. So it is 2 by s. So, and he has given in the question x dash and x of 0 is equal to 0. So these values will become 0. So remaining is s square into x of s plus 2 into s into x of s plus 2x of s is equal to 2 by s. Now taking x of s common, you get s square plus 2s plus 2 is equal to 2 by s. So therefore from this x of s is 2 by s into s square plus 2s plus 2. This is your Laplace transform value. Now he has given in the question to solve that Laplace transform. That means you have to find the x of t value. You have to find out the x of t value. Okay, so now first apply. So what you have to do, you have to apply inverse Laplace transform. So Laplace inverse Laplace transform of x of s is equal to inverse Laplace transform of 2 by s into s square plus 2s plus 2. So what we have, what we know, Laplace transform of x of t is what? X of s, right? So what will be inverse of it? Laplace transform of x of s will be equal to x of t, right? We know already that Laplace transform of function is x of s. So inverse of this Laplace transform will be Laplace transform of x of s will be equal to x of t is equal to inverse of this. Now we have to solve this equation so that you can derive the final x of t. So let us consider this part only. 2 by s into s square plus 2s plus 2. Consider this function 2 by s square plus 2s plus 2. Now split this function into partial fractions. A by s plus square quadratic term. So bs plus c by s square plus 2s plus 2. I hope you all know how the partial fraction splitting takes place. I don't want to explain that right now. If you don't get, please let me know. I'll let you all explain. I hope partial fraction is clear here. A by s plus quadratic term. So bs plus c is equal by s square plus 2s plus 2. Now take LCM. 2 by s into s square plus 2s plus 2. Splitting into partial fraction. So a into s square plus 2s plus 2 plus bs plus c into s by s square plus 2s plus 2 into s. I hope this is clear. This is taking LCM. LCM s into s. So this will be a into s square plus 2s plus 2 plus bs plus c into s by s into s square plus 2s plus 2. Right? Right or not? LCM. So these two sides, these two terms will get cancelled. So 2 is equal to expanded as square plus 2as plus 2a plus bs square plus cs. So 2 is equal to s square terms common a plus b plus s terms common 2a plus c. Constant 2a. Constant term is 2a. So now comparing on both sides, this is equal, right? You are taking these two as equal. So you will compare. So is there any s square term here? So no. So a plus b is 0. Is there any s term on this left hand side? No. So 2a plus c is equal to 0. Is there any constant term? Yes. So 2a is equal to 2. So therefore a value is 1. So if a is equal to 1, what is b? If a is equal to 1, substitute in this equation. A plus b is equal to 0. A is equal to 1. So b is equal to minus 1. 2a plus c is equal to 0. Substitute a value. 2 plus c is equal to 0. C is equal to minus 2. We got the value of a, b and c. Now you substitute this function 2 by s into s square plus 2s plus 2 can be written as a by s, so 1 by s plus b is minus, c is also minus, so you can completely take minus common. B is s plus c value is 2 plus, what is this, minus s minus 1s minus 2 by s square plus 2s plus 2. Can it be written like this? Okay? Is it okay? Can we write this function like this? Right. So partial fractions we have done. Now our aim is to find Laplace inverse of 2 by s into s square plus 2s plus 2, which is equal to Laplace inverse of 1 by inverse Laplace transform of 1 by s plus 1 by s plus minus s minus 2 by s square plus 2s plus 2. Now Laplace inverse, you can split this as inverse Laplace transform of 1 by s. You can take minus common here, minus inverse Laplace transform of s plus 2 by s square plus 2s plus 2. Right. Now what is Laplace transform of inverse of 1 by s? What is Laplace transform of 1 by s? Isn't it? Laplace transform of 1 constant k by s, na? So 1 is 1 by s. So inverse Laplace transform of 1 by s will be 1. Inverse Laplace transform of 1 by s will be 1. Now this function, you don't have any formula for this square plus 2s plus 2. Now this s square plus 2s plus 2 can be written as s plus 1 whole square plus 1. Can it be written like this? What is s plus 1 whole square? A square plus b square. A square plus b square is b square 1 plus 2 into a into b, 2 into s into 1. So what is it? S square plus 2s plus 1. 2s plus 1. So but here you have 2s plus 2. 2s plus 2. Right? So you can write it as s plus 1 whole square plus 1. If you add 1 to this, what happens? S square plus 2s plus 2. Right? So s plus 1 whole square plus 1. This function can be written as s square plus s plus 1 whole square plus 1. So Laplace transform, inverse Laplace transform 1 by s is 1 minus inverse Laplace transform of s plus 2 by s plus 1 whole square plus 1. Now 1 minus Laplace inverse of, I'll write it as s by s plus 1 whole square plus 1 minus of whole, no, so again minus 2 by s plus 1 whole square plus 1. I am further splitting this, so 1 minus Laplace take s plus 1 plus 1. S plus 1 plus 1 will be giving you s plus 2, right? You are just splitting that. Now Laplace, inverse Laplace transform of s plus 1 by s 1 whole square plus 1 can be written as 1 square. So you are taking it a square by s square, s by s square plus a square, e power minus at cos at cos kt. What is the Laplace transform of this? E power minus at cos kt, s by s plus a whole square, s by s plus a whole square, s plus a by s plus a whole square plus k square. Isn't it or not? Laplace transform of e power minus at cos kt is s plus a by s plus a square plus k square. Inverse Laplace transform will be e power minus at cos kt. So is it not in this form? S plus a, s plus 1 by s plus a whole square, that is s plus 1 whole square plus k square. A and k are 1 here. So Laplace transform of this function will be e power minus 1t into cos kt is k is also 1 here. So cos t. Right? Isn't it or not? Now what will you write for e power minus at sin t sin kt? What is the Laplace transform of e power minus at sin t? A by s plus a whole square plus k square. A by s plus a whole square plus k square. Sorry, k by e power minus at sin kt. What is the Laplace transform of e power minus at sin kt? K by s plus a whole square plus k square. So k can, if your k value is 1 and a value is 1, then it's not this 1 by s plus 1 whole square and plus 1. 1 can be written as 1 square, right? So 1 by s plus a square plus k square. So it is minus e power minus at sin t. At sin t is 1. So e power minus t into sin kt. K also is 1. So this is your Laplace. For solving the differential equation, you have to solve like this. So in 1 minus e power minus t common, cos t plus sin t. So this is your x of t. This is how you solve the problem. Okay? So in the same way, if you still have doubt, repeatedly watch this video, you will clear it out. I give you 2 more problems to solve this so that you can get practice. Solve the differential equation d cube x by dt cube plus 2d square x by dt square minus dx by dt minus 2x is equal to 4 plus e power 2t. 4 plus e power 2t, where x of 0 is equal to 1, x dash of 0 is equal to 0 and x double dash of 0 is equal to minus 1. Solve this problem. D cube x by dt cube plus 2d square x by dt square minus dx by dt minus 2x is equal to 4 plus e power 2t, where x of 0 is 1, x dash of 0 is 0, x double dash of 0 is minus 1. These are the values, initial values or required values, given values. You have to solve this function. So first step is to apply Laplace transform on both sides. Laplace transform on both sides. You get the function x of s. Then x of s should undergo partial fractions, or if required. Otherwise, if simple terms are there, you can factorize, or easily if they are able to separate, then you can easily separate and do it. Okay? Is it okay? Yeah, so partial fractions you have to apply and get it into simpler forms. Then apply inverse Laplace transform to x of s will give you x of t. That will give you x of t. Solve this. So this is what is the basics for